Okay, let's start Chapter 2. In Chapter 2, we'll be solving equations, which we've been doing all along. We're going to look at some more difficult ones, but for right now, let's look at some stuff we probably already know. Okay, so an equation is called linear. This is an important definition. If the variable only appears to the first power. And remember, we think about that as having no variable, or no exponent. Okay, so for example, x is really x to the first power. Okay? And to solve an equation means to find the value of the variable that will make the equation true. Okay? And so there are some things that we've been doing all along that help us do this. We can add or subtract the same term to both sides of the equal sign in an equation. So for example, if I wanted to solve for x, I have to undo what's happening to it. Right now, 7 is being subtracted from x, so I could add 7 to both sides. So we'll get x is equal to negative 2 plus 7 is positive 5. Okay. And it makes the equation true, because I could check it. 5 minus 7 equals negative 2. Negative 2 equals negative 2. This is true. It checks. But I don't have to just add constants. I could add the entire term. So here I have 2x's and here I have 3x's. So to get all the variables on one side, I could subtract 2x from both sides. Now 2x minus 2x is 0. So we're only left with a 3 on this side. And if I have 3 x's and I take away 2 of them, I'm left with a single x. Okay. Remember, you could write the 1 there if you wanted to. That's fine. Okay. And now x is by itself, so this is solved. And we could check it. 2 times 3 plus 3, does that equal 3? And I say x is 3. Right, so for here, we said x was 3. Or 6 plus 3, does that equal 9? Sure, it does. We can also multiply and divide on both sides of the equation by the same number. Okay. So in this case, I have 3x's is equal to negative 15, but I don't want to know about 3x's, I want to know about a single x, so I could divide both sides by 3. Then those 3's would cancel, leaving with just an x. And negative 15 divided by 3 is negative 5. Okay. Again, we'll do the check. 3 times we say x should be negative 5, and ask ourselves, does that equal negative 15? And sure, negative 15 equals negative 15. So it checks. Okay. On this one, I have 1/2 of x is equal to 7. But I don't want to know about 1/2, I want to know about a single x. So if I multiply this side of the equation by 2, and this side by 2, then 2 times 1/2 is just 1. So we'll have x is equal to 14. And with the check, then 1/2 of 14, does that equal 7? Sure, half of 14 is 7, so 7 equals 7. So these are real basic ideas about equations. So here's some more. Of course, we're going to have to do multiple steps, right? So in this case, I want to undo everything that's happening to x. So let's first add 17 to both sides. Okay. Then on this side, we have 4x's is equal to 9, and 7 is 16. Carry the 1. 1, 2, 3. So 4x's is equal to 36. And now I don't want 4x's, I want just a single x. So the 4's will cancel. So x will be equal to, and 4 goes into 36 9 times. And we'll do our check. 4 times 9 minus 17, does that equal 19? Well, 36 minus 17, does that equal 19? Yes, 19 equals 19. Over here now, we have x's on both sides of the equation. This has a negative sign. This is positive, so let's add 3x to both sides. So this becomes 5x's plus 3x's is 8x's, minus 8. This goes to 0, is minus 40. Now I'd like to add 8 to both sides. So on this side we'll have 8x is equal to, now here, remember, I have the negative and the positive, so let's subtract as normal to get 32. But I want to take the sign of the larger number, and 40 is negative, so our answer will also be negative. Now finally we can divide by 8. So the 8's will cancel, and we have x is equal to 8 goes into 32 4 times with the negative. Let's see if we can do the check over here. 5 times negative 4 minus 8, does that equal negative 3 times negative 4 minus 40? 5 times negative 4 is negative 20 minus 8. Negative 3 and negative 4 become positive 12 minus 40. On this side we have negative 28. And 40 minus 12, subtract as normal. I'll have to borrow 1, so that's 8. And 3 minus 1 is 2. But we'll remember we'll take the sign of the larger number. 40 was negative, so this is negative 28. Okay. So our answer checks. It's important that you do the checks on your homework. On your exam, you'll be asked to check your work, and it will be worth points. Okay, so practice doing that now. And the important thing to note is before we start adding and subtracting everything, let's simplify either side. Okay. So for example, on this side, I have x minus 3x. That will combine to become negative 2x. Then plus 7. And on this side, I have negative 4 minus 9. I can combine those like terms to negative 13 plus 2x. Now that each side is simplified, let's try and solve for x. Since this one's negative and this one's positive, let's add 2x to both sides. Now this will go to 0, so 7 is equal to negative 13, and 2x and 2x is 4x. Now I'd like to undo what's happening to x, so let's add 13 to both sides. So 20 is equal to 4x. And finally dividing through by 4 on both sides, the 4's will cancel, so we have x is equal to 5. Okay. On this one, we can also simplify. Let's do the distributing through first of all. Okay. So we'll get 5x's minus 20 on this side is equal to, and over here, let's distribute the 2 to get 2x's plus 18 plus 4. Now let's see if we can simplify each side. Now this side is already simplified. There's no like terms to combine. However, here, I could add the 8 and the 18 and the 4, so the 2x will stay by itself, and 18 plus 4 is 22. Now we can solve for x, so let's subtract 2x's from both sides. So 5x minus 2x's is 3x's. The minus 20 stays. This goes to 0, and we have 22. So 3x's, now let's add 20 to both sides. So 3x's is equal to 42. And dividing by 3, we'll have x is equal to So now the question becomes, is 42 divisible by 3? So let's remember our rule. If a number is going to be divisible by 3, let's add up the digits. So 4 plus 2 is 6. 6 is divisible by 3. So 42 is divisible by 3. So let's do the long division. 3 goes into 4 one time. 1 times 3 is 3. And then we'll subtract and bring down the 2. 4 goes into 12 4 times. Okay. 4 times 3 is 12. Subtract 12. There's a remainder of 0. So we know that x is equal to 14. Okay, so let's continue with these and keep simplifying first. So let's distribute. Now the important thing here is when we distribute, we're distributing not just a 5, we have to distribute that negative 5 since it's being subtracted. So the 3 will stay. This is minus 5x, and then a negative 5 times a negative 2 is positive 10. And the right-hand side is simplified as much as possible. Now let's combine like terms on this side. 3 plus 10 is 13. Minus 5x is equal to x plus 7. Now we can solve for x. This is negative and has a larger coefficient than this, so let's add 5x, so when we're done we don't have to divide by a negative. Okay. So on this side we have 13 is equal to 1x plus 5x's is 6x's plus 7. And now if we subtract 7 from both sides, we have, let's see, 13. 6 is equal to 6x, so x must be equal to 1. Now let's check this, and we have to put it back in the original. So 3 minus 5 times, what are we saying x is? X is 1 minus 2, and we're wondering if that's equal to x, which is 1 plus 7. So put it back in the original. And now let's simplify using the order of operations, and this is what we're asking ourselves. So 3 minus 5, we have to work inside the parentheses first. So this becomes negative 1. And on this side, 1 plus 7 is 8. Now following the order of operations, we have to do the multiplication next. So the 3 will stay the same. And a negative 5 times a negative 1 is positive 5. And is it that 3 plus 5 equals 8? Yes, it's true. It checks. Let's do this one. Okay. Let's add 4 to both sides. So we have 1/3 of y. Negative 4 plus 4 is 0. Negative 8 plus 4 is negative 4. Now I have 1/3 of y equals negative 4, but I don't want 1/3 of that. So I need to multiply it by 3 over 1. These are reciprocals. Okay? I have to do that on both sides. 3 over 1 is just 3. Okay? So these cancel, become 1, so we have y is equal to negative 12. Okay? Now let's check our answer with that. Okay? Is it that 1/3 of y, but we've said y is negative 12. Remember, we can write that as negative 12 over 1. If we take that and subtract 4, will we get negative 8? Okay. Now, following the order of operations, we have to do the multiplication first, and let's do the canceling. 3 goes into itself once, and then into negative 4, or negative 12, negative 4 times. Okay. So this becomes negative 4 over 1, which is just negative 4. And is it true that negative 4 minus 4 is negative 8? Yes, this is true. It checks. Okay. While doing your check, you'll also get much quicker with calculations. Okay, so here's some more. Let's solve and check. So in this case, let's add 2 to both sides, 2 x's. So we have 5 is equal to 6x plus 11. And now undoing what's happening, we'll subtract the 11. So 5 minus 11 is negative 6. On this side we have 6x. Okay. This is 0. Now dividing by 6, we get x is equal to negative 1. Okay. And let's check ourselves. So putting back into the original, our original says take 5, subtract 2 times x, and will that be equal to 4 times x plus 11? And we said x is negative 1. Now following the order of operations, we'll have to do the multiplication. So a negative 2 times a negative 1 is positive 2, so that turns to an addition, is equal to, and here, negative 1 times 4 is negative 4 plus 11. Okay. So 5 plus 2 is 7, and negative 4 plus 11 is also 7. So our answer checks. Okay, on this one, let's do our distributing to simplify. So this side is 2w minus 18. Does that equal w plus, and then we also have some distributing to do here, 3w minus 18. Now let's simplify both sides. So 2w minus 18 is equal to, on this side, we can combine these to get 4w, and the minus 18 will stay. Now let's add 18 to both sides. Okay. When I do that, on this side I'll have 2w, this goes to 0, the 4w comes down, this also goes to 0. Okay. Now let's subtract 2w from both sides. Okay. So on the right hand side we'll get 0 is equal to 2w. And now dividing through by 2, we'll get w is equal to, well, 0 divided by anything except 0 is 0. And let's do the check. So 2 times 0 minus 9, is that equal to 0 plus 3 times 0 minus 6? So let's put in this 0 minus 9, 0, 0. So this becomes, well, 0 minus 9 is just minus 9. 0 plus anything is just itself, so this is 3 times negative 6. And is it true 2 times 18, or I'm sorry, 2 times negative 9 is negative 18, and 6 times 3 is 18 with an 18, negative 18. So this also checks. Okay, let's try the next one. Again, we'll simplify on the right-hand side by distributing first. The left-hand side is already simplified. Minus 5y plus 7 is equal to negative 2y minus 4, distribute the negative, okay, and then plus 11. The left-hand side is already simplified, so we'll just copy that. Okay. But on the right-hand side, negative 4 plus 11, that's 7. Okay. Now let's use the same trick we did above. Let's subtract the 7s. Okay. So in this case, we'll have negative 5y is equal to negative 2y. Okay, the 7s will cancel. Okay. And then adding 5y. On this side, we'll have 0. And then negative 2y plus 5y is 3y. So we'll divide by 3. Okay. On this side, the 3's will cancel. And 0 divided by anything but 0 is 0. And now let's do the check. Negative 5 times 0 plus 7. We're going to ask ourselves, is that equal to 2 times 0 plus 2 plus 11? Okay, so we say y is 0. Now 0 times anything is 0 plus 7. This is negative 2 times, working inside the parentheses, 2 plus 11. 0 plus 7 is 7. Negative 4 plus 11, yes, 7 equals 7. Okay. Now let's solve this one. Again, simplify left and right hand sides. Just be careful this time. When you're distributing that negative 4 because there's a subtraction there. So we have t is equal to, now, negative 8t minus 12. And does that equal, well, it does equal negative 6t plus 20. So here we'll combine our like terms. If I have 1t and I take away 8t's, I have negative 7t's left. Then minus 12 is equal to negative 6t plus 20. We have t's on both sides. They're both negative. This is the larger one, so let's add 7t. So we get negative 12 is equal to negative 6t's plus 7t is a positive 1t plus 20. And now we can subtract 20 from both sides. So we'll get t is equal to negative 30. No, negative 32. And let's do the check. Okay. So, let's see here. Putting back into the original. Okay, and we said t is going to be negative 32. Minus 4, 2 times negative 32 plus 3, negative 6 minus 32. Alright, so we have to work inside of here. So this is negative 32 minus 4 times, okay, 2 times 32 is negative 64 plus 3. And then here, negative and negative will become positive. 32 times 6. 6 times 2 is 12. Carry the 1. 6 times 3 is 18. Plus 1 is 19. So this is 192 plus 20. Okay. Now, still working with the order of operations. Negative 64 plus 3 is negative 61. And does that equal 192 plus 20 is 2, 11 carry the 1, 212. Now here, again, continuing to follow the order of operations, the negative and the negative will become positive. 61 times 4. 4 times 1 is 4. 6 and 4 are 24. Okay, so plus 244. Does that equal 212? And we're almost there. Now we have negative 32 plus 244, so let's subtract 32 from that. 2, 1, 2, and the sign of the larger number, which is positive. So it checks. Okay, now some other things can happen when we're solving equations. Okay. One of them is an identity, one is a contradiction that we'll see later. Okay. So some equations will have more than one correct solution. Okay. We'll see this later in the course. And in fact, some of them have an infinite amount of solutions. And when that is true, when you have an infinite amount of solutions, we call that equation an identity. It's an equation that is true for any real number that you substitute in for the variable. Okay. So here's an example and let's see what will happen. Again, so let's simplify on the left and right hand side. Distribute the 3. 3x is plus 12, and then the minus 2. Okay. Now let's combine like terms. Okay, so on this side, x plus 2x's becomes 3x's, then plus 10. And on this side, 3x, when you combine these two, this also becomes plus 10. Now, if we try and solve for x, okay, we could subtract 10 from both sides. So we have 3x's is equal to 3x's. And now, dividing by 3, on each side we have x is equal to x. So this is true. No matter what value x I put in, it will equal itself. So this is an identity, and its solution will be all real numbers. Let's try this one and see how else it could look. So on this side, 7t minus t becomes 6t plus 8. And then on the right-hand side, let's distribute. So we'll also get 6t plus 8. Let's say we did it a different way. If we subtracted 8 from both sides, we'd be in this situation again, where we'd have 3x's equals 3x, except it'd say 6t equals 6t. So let's say I wanted to try and get the t's on one side, and I subtract 6t. Well, then on this side we would get 0 plus 8, which is just 8, and on this side we get 0 plus 8. So this is another way. 8 does equal 8. If we get something like this, it is a true statement. It is an identity, and the solutions will have to be all real numbers. So anytime you come up with some type of a true statement, you are dealing with an identity. Now the other thing that can happen is these things called contradictions, and sometimes when an equation has no solution, there is no number that will make the iteration true. So it is a contradiction to say that it's an equation, because there is no equality. Okay. So let's see what that could look like. Okay. We'll simplify on the left and right hand sides. On the left, there's nothing to simplify. And on the right, we could distribute. We get 2x's minus 6 plus 4 minus x. Again, the left-hand side is simplified. On the right-hand side, though, 2x's minus x, well, that's just an x. And then here, negative 6 plus 4 is negative 2. Okay. Now let's add 7 to both sides. So we'll have x is equal to x plus 5. And if I try and solve for x now, let's get all the x's on one side. On this side, we have 0 is equal to 0 plus 5, okay. And this is false. Okay. So when you come up with that, when you come up with a not a true statement, 0 does not equal 5, then you are in a contradiction. That equation is a contradiction. Okay. And for the solution, we say there is no solution. Okay, so those are all the various types of things that can occur with equations. We've been doing them, solving equations, so this is really the newest part. And also, I'm going to really encourage you to do your check on your homework. You are instructed to check your solution. That is part of the points for the problem. Make sure that you do that. I'm here. Let me know if you have any questions. Send me an email.